All right. So this is the second half. The second half of lesson 3.6, which is talking about inverse functions. So what we're going to learn now is how to create inverse functions. We've learned, like earlier in example 2, how to tell if they are inverses. Now we're going to start with 1 and see if it becomes an inverse. Yeah. So on this one, what we're going to do is we're going to find inverse of f. So what they're looking for is inverse of f, which is basically just 4 steps here. Okay. One is you need to verify that the inverse does exist. A quick way that you can do that is by graphing. And when you graph, it should either always increase or always decrease. Okay. Some of them you may or may not know how they look. Do you guys know how that looks? How could you find out how that looks? Well, it's already solved. This guy back there. You graph it. How? How could you? So you want to get like your x and y table and just do a whole bunch of dots and then eventually connect the dots? That'd be one way. What's another way that might be a little bit quicker? Use a calculator, right, to graph it. And we're looking for, when we graph it on the calculator, what are we looking for to know if it's got an inverse or it doesn't have an inverse? Remember, back here it says, keep on going. Where the function is increasing or decreasing throughout the entire, so it's always got to be increasing or always decreasing, which means it has no hills on it, right? So I'll just tell you guys, and hopefully you'll believe me, but this one right here looks, let's see, if this is my x, y table, looks like this.
Yeah, it looks stupid.
All right, is that always increasing? Yeah, it is. So when we verify it, we just want to make sure that it has an inverse. All right. So it's always increasing, though. Yeah. It doesn't matter if it's increasing by a lot or a little. It's just yeah. Nah, kind of. Yeah. I think it depends on, if you zoomed in, I think it'd look a little bit more like this. If you zoom out, it just kind of looks like a straight line. All right, so on step 2, replace. And what we're going to do is we're going to take, this right here is a name, right? And what does it stand for? Like what used to be, yeah, y. So it used to look, I mean, like this, right, with our x and y in there. That's a 1. All right, so when we talk about replace, I'm going to replace these two, or switch them, basically. So I'm going to take x over here, and I'm going to put y, oops, I don't know why I've made it 2, and y here, and now we need to do, so that's replace, and then we need to solve. Okay. So when we solve, we're going to get y by itself. That's the idea. I mean, you switch them, and then solve for y and get y by itself, and that's the inverse function. And that comes back to when we said that the inverse functions, the domain becomes the range, and the range becomes the domain, which basically means we're switching x and y variables. All right. So how can you get rid of that square root sign? Yeah. That'll do blue. Square it. And those, eliminate, now you have x squared is equal to y minus 1. Still trying to get y by itself, right? Plus 1, plus 1. X squared plus 1 is equal to y. All right, so that's the replace part. So step 4 is find the domain. Okay. Now remember, when we have inverse functions, the domain of one is the range of the other, and the range of one is the domain of the other. So if I'm looking for domain here, so down here I want domain. The domain down here is going to be the same as the range up here. All right. These two, isn't this one, and this one, aren't those inverse functions? So the domain down here where I wrote the 1 is the same as the range up here where I wrote 2. What's the range of this equation here? Well, it goes to positive. Okay, so it goes to positive infinity. This is going to go eventually up to positive infinity. Where does the range start? Right, we're talking about range is y's. So down here, it starts at y is equal to 0. So the range here is, let's see, it includes 0, but then it goes to positive infinity. So what's the domain of my inverse function? The exact same. Comes from the range domain, right? Up there, the range, down here's the domain. So those are exact opposites, yes. Yeah, like you can never actually equal infinity, so we're going to have a parenthesis instead of a bracket. I mean, it's kind of a technicality thing. I'm not going to mark it wrong, I don't think, if you did it, but some mathematician at some time decided that had to be a rule. All right. Now, let's think about what it means for a second. Scroll down. If I think about this, right, x squared plus 1, we should know now that that 1 is like this, isn't it? And does that pass the horizontal line test? So did what I draw a one-to-one function? No. Okay, it's not a one-to-one function, and it doesn't have an inverse. But we restricted the domain, didn't we? Right here, we restricted the domain. So really, we're only talking about drawing in black. Now, what I drew in black, is that a one-to-one function? Yeah, we just restricted the domain to where it was. Okay? So this graph, even though it makes parabola, we're only using half of the parabola. We're only using the increasing part of the parabola. All right, any questions? 2. Okay, so here we have a research department for electronic demand for a certain brand of headphones given by this equation. X is the number of pairs retailers are likely to buy per week at $P per pair. Express the revenue as a function of the demand, X, and state its domain. Right. So what we want to do is we want to change, let's see, price, revenue. Okay, so what they have right now, they have f of P is equal to 20,000 minus 1,000 P, where this is X, which is the numbers, this is the number, and then this P is price. They want us to change the equation so it has price equals, and then, you know, something over here with headphones inside there. So they want us to make basically the inverse function, right? So we're going to follow the same steps to do that. Let me. So we're going to the same steps. One is we should see that this is linear, right? And a linear equation always has an inverse. So we're fine with the verification. Then we need to switch the variables. So I'm going to put P over here, and then on the inside, I'm going to put X, which stood for headphones. Okay. Base. A number for. Oh, wait. Hold on. Let me back up a second, okay? Because if I did something wrong. All right. So what I'm going to do is I'm actually going to leave this. I'm going to leave this as P, and over here is X. Okay. What we want to do is we want to get P12. All right. Yeah.
Okay, you
This is just the name, right? This really stands for numbers of headphones. Okay, this is the price. So basically what this first equation up here gives us, the first equation up there gives us, it says, as a company, if we set the price of headphones at P dollars, so if we set it at $10, we're only going to sell a certain amount of headphones. So for $5, are we going to sell more or less headphones? More headphones, right? But what we want to do is we want to turn it around. Okay, we want to say, hey, we know we can sell 7,000 headphones. How much price in order to sell them, right? There's a certain number. So what we're going to do is we want to get P by itself. So the idea here is we're going to get this P by itself. And then those two will be inverse functions of each other. How can I get this P by itself? Subtract the 20,000, which gives me x minus 20,000 is equal to negative 1,000. All right, and then I divide by the negative 1,000. We have to divide by negative 1,000. Everywhere you give me plus 20. P, and this is going to be, I could write it like this, negative 1, or 1 over negative 1,000 x, or you could have x over negative 1,000. Either way works. Okay. So this is now the inverse function of that original equation they came up with. Okay, and how does this differ? Well, it tells me for if I want to sell this many headphones, the price has to be this much money. Okay, so let's say that we have, we're going to shut down the plant for a little while, and we have 2,000 headphones in surplus. Okay, so I want to sell 2,000 headphones. Well, what we could do is we could say, okay, I have 2,000 headphones. I want to sell each, but I don't want to sell them for a penny each. I want to make money. So if I took 2,000 and I plugged it in for x here, I'd get 1 over negative 1,000 times 2,000 plus 20 is equal to P. If we do our multiplication here, I believe we get negative 2 plus 20 is equal to P. Negative 2 plus 20. How much are we selling each headphone for? $18. I don't know why that did that. $18. Now, could you see why it would be useful if you were like the manager or the owner of this electronics firm to know both of these equations? To know both. If I sell it, if the price, if I want to make this much per dollar per headphone, this is something else per week. If I want to sell this many per week, how much do I sell it for? Right. And there's advantages to knowing each one. Oh, I guess I gave myself room over here to write, so I didn't have to make it all confused. But, all right, so here, let's see, I think I was supposed to, yeah. So here I'm going to make f of x and inverse of x. So let me try to draw this as best I can. All right, so here I have two functions. We'll call this f of x and this inverse of x. That green line there is what we call the x equal, or the y equals line. And we notice it goes through 0, 0, goes through 1, 1, goes through 2, 2, goes through 3, 3, right? So it makes this dotted line. Anytime you have an inverse function, it will be reflected over that x equals y line. Do those two look like reflections? To use a little bit of imagination. Yeah. Oh man, I made my arrow backwards. There you go. So it looks like they should be reflected. Anytime that you graph two of them, it would look like it was reflected over the x equals y axis. All right. An example of that is the one that we found earlier, square root, right? I think it was example 4 or something like that. Should have probably looked like this, I think. And then the x squared one would have been like this. Those kind of look like they've been reflected over the y equals x line. Yeah. I mean, it's best to make it look. Yeah. Let's say we took x squared with the restricted domain of 0, infinity, and we'll so this top one, here, I'll graph this top one in red, looks like this. So it kind of looks like that. So it kind of starts off below. And then the second one, which I'll do in green, will look like this. So they can't cross each other.
That's what kind of function it is?
This one right here, radical. A lot of times we'll call it square root because it's a square root sign. Everything. You guys got the assignment yesterday, so go ahead and get started or finish it up. We'll call it good.